Hello friends and my dear students, I welcome you all to my channel. If you are new to my channel or not yet subscribed, and if you are watching my videos and finding them beneficial, then I will highly request and suggest that you please support me by subscribing to my channel, like my videos, share them with your friends, and also do not forget to press the bell icon so that you will be notified by my future videos. In this video, I will solve few practice problems. This is sample number 1 based on the chapter decimals of all the topics that I have covered in classes 1, 2 and 3. If you have not watched the previous 3 videos on classes 1, 2 and 3, I highly suggest that you watch them first before solving these practice problems. And if you have already seen those videos, then you can pause the video and solve all the problems yourself, and then you can see my solution if you are stuck at any problems. So let's get started with this video. Okay, so on the left hand side, I have kept the PDF of the sample problems, practice problems, sample number 1 that we will solve. And but before solving these problems, I would like to discuss one thing on the right hand side. How do we convert a decimal fraction to a decimal? What is a decimal fraction? A decimal fraction is where the denominator is like 10, 100, 1000, that is a power of 10, where the power is a natural number. So, and we have to convert this kind of fraction to a decimal. Now, there are 3 steps involved. So, if the decimal fraction is p by 10 to the power n, where p is the numerator, and of course the denominator will be of the form 10 to the power n, where n is greater than equals to 1, that is a natural number. Now, first what we do is we add as many zeros to the left of p such that the number of digits in p becomes n. So, if the number of digits in given p is less than n, we add as many zeros to the left of p so that the total number of digits now in p becomes equals to n. And if the number of digits in p is already greater than n, then we need not do anything. We will leave p as it is. Now, the second step is add a decimal point in p after n digits from the right. So, in p, now you add a decimal point after n digits from the extreme right of p, and finally the required decimal will be p. So, p will now be the required decimal. Let's try to understand this through an example. Let's say, how do we 13 by, let's say 13 by 100, how do we convert this? In the previous videos, in the conversion of fraction to a decimal, we have discussed by doing the division. That is, we divided the numerator by the denominator and we got quotient and remainder, and then we added the decimal point and a 0 to the right of dividend and 0 to the remainder, and proceeded with the division until the remainder was 0. So, that was using a long division method. Now, if the fraction is a decimal fraction, then it's much easy. Okay, so how do we convert this decimal fraction 13 by 100 to a decimal? So, we see that the number of digits in the numerator 13 is 2, and also the number of zeros in the in 1 is in the denominator. I mean 13 by 100 is nothing but 10 to the power 2. So, over in the discussion, n is basically the number of zeros in the denominator after 1. So, this is 13 by 10 square. So, we already see that the numerator has 2 digits, which is equal to n here, which is 2. So, we need not to add any zeros to the left of numerator, and we now simply add the decimal point 2 digits from the right in the numerator. So, after 2 digits, so this becomes 0.13. Let's say you have given a number 756, 756 by, let's say 100. So definitely we see that 756, the number of this is 10 square, so n is 2. So the number of digits in numerator is 3, which is already greater than 2. So we did not add any zeros to the numerator. So what we do now is we add the decimal point to the numerator, 2 digits from the right, 2 digits from the right, and so it becomes 7.56. Let's say what we have to convert 4 by 1000. So this is equals to 4 by 10 to the power 3. So n is 3. Now we see that the number of digits in the numerator is 1, which is less than 3. So what do? We add as many zeros to the left of the numerator so that the total number of digits in the numerator becomes equals to n. So in this case we have to add 2 zeros and becomes this. We can obviously add zeros to the left of any number. We know it makes no difference. Now what we do is we add the decimal point in the numerator 3 digits after 3 digits from the right. So this becomes 3 digits. So we put the decimal point. So this becomes 0.004. Let's check another final example. Let's say 25 by let's say 1000. So this becomes 20. This is 25 by 10 to the power 3, and we see there are 2 digits in the numerator which is less than 3. So what we do is we add zeros to the left of numerator so that the total number of digits in the numerator becomes equals to 3. So we have to add 1 0, 0 to 5, this, and then finally we put the decimal point in the numerator after 3 digits from the right. So it becomes, you can omit this 0, I mean it means the same, 0.004 is equals to 0.004. So this is the decimal number. Okay. Another just as a side note or tip is that if you are given a fraction and you are asked to convert it to a decimal number, let's say if you are given a fraction p, where p is a numerator, and let's say the fraction is p by q, but q is not a power of 10. Q is not a power of 10. P by q is not a decimal fraction. So, but q is a number. Q is a natural number, which, if you can see that q is a natural number which you can easily convert to a number of the form 10 or 100 or 1000 or 10,000 by multiplying it with a number, then you can do that, and after and then you can multiply, you can make the q in the form of 10 to the power something, and whatever number you are multiplying q, you have to multiply that number also with the p. So you will get a decimal fraction, and from the decimal fraction, using this concept, you can easily convert it to a decimal. Let's say you are asked to this. I mean, you can easily find it out by doing a long division, but sometimes it will be more easier if you follow this step. So so you can clearly see that this is not a decimal fraction. The numerator 20 is not a power of 10. So, but you can see that clearly if I multiply 20 by 5, it will become 100. So I will first convert it to an equivalent fraction, so that the fraction will become a decimal fraction. So what will I do? I will multiply denominator and both numerator by 5. So this becomes 90 by 100. Now I will apply, now this is a decimal fraction 90 by 100. Now I will apply the concept just I discussed right now. and I will convert it to a decimal. How? I can see that the number of digits in the numerator is same as the number of zeros or the power of 10 in the numerator. So we need not do anything, and we will just put the decimal point in the numerator 2 digits from the right. So it becomes 90. Sometimes this is convenient. You are given a fraction which is not a decimal fraction, but you can see that you, by doing some multiplication with a very easily you can convert the denominator to a power of 10. Then you can convert it to a decimal fraction, and then from the decimal fraction you convert it to a decimal. So that was a little side note I wanted to discuss before solving the problems. Now let's solve the problems. Okay. So number 1. So these are the problems which will try to solve. Okay, try to. We have 10 questions. We have 10 questions. Try to solve these questions in less than 45 minutes, meaning roughly 3.5 minutes or 4 minutes per question. Then you are good. But even if it takes 1 hour, it's fine. But ideally, within 40 minutes or 45 minutes, try to complete the try to solve all these problems. Okay. So first one says subtract 18.569 from the sum of this and this. Okay. So it is asking to subtract from the sum of 208.056 plus 48.685. From the sum of this, it is asking to subtract 18.569. So this is kind of simplification of decimal numbers where we have the multiple addition and subtraction operations. In this case, we have one addition and one subtraction. So what we will do is we can see that all the decimal numbers are like decimals because they have decimal places of 3. So we will first, if we do this, if we evaluate this first, this becomes, I will quickly, so how do you add decimals which are already like decimals? So you write all the decimals in the column form, one below the other, and in the column form one below the other, so that the decimal points are in the same column and the respective digits of the decimal part and the whole part are in the same column, and then you add just like whole numbers. So this becomes 11 and 6 14 and 7 16 5 2. Finally you put the decimal point. Since the decimal places of the two decimal numbers is 3, you put the decimal point in the result after 3 digits from the right. So 3 digits from the right, here will be the, so this becomes, the addition of these two decimals becomes 256.741. Now we have to do this subtraction, and these two decimals are also like decimals. So how do we subtract? We write the bigger decimal first, and below it in the column form we write the smaller decimal number, and we do the subtraction just like whole numbers, and this becomes 2 11 and 7 7 6 1 8 3, and you put the decimal. So this is the result of the subtraction. Now I have to put the decimal point. The decimal point will be 3 digits from the right here, because the decimal places of the two decimal numbers is 3. I hope I have this option in the, yes. So this is the answer. This is the result. So as per the this is an MCQ. As per the choice will be B, 238.172. Okay, let's do problem number 2. What number is equal to this? Okay, so we have to evaluate, it's a decimal, 0.02 divided by 0.002. Even though I have not discussed the division and multiplication of decimal numbers, I have still included this problem uh, because we can use the concept of converting a decimal number to a fraction, and we have done the division of fraction, multiplication of fraction, and the addition of fraction. So we will convert the decimal numbers to a fraction, and we'll do the operation using fractions. Okay. So if I convert in the first term, if I convert the numerator, that is 0.02 to a fraction, what it will be? So how do we convert a decimal number to a fraction? We first write the decimal number without omitting the decimal point. So this becomes 002, and then divided by, we divide by 1 and put as many zeros as the decimal places of the number. So we have point in 0.02, the decimal places is 2, so we will put 2 zeros. So this was, so we converted 0.02 to 002 by 100. Similarly, I will convert the numerator of the first term, of the denominator of the first term, to a fraction, and it will be 002 divided by 1000, and we have this. Similarly, the numerator of the second term, the second fraction, is 002 divided by 100, and we have divided by 2. Now 002 is equals to 2. Obviously, leading zeros in a whole number makes no sense, is meaningless. So now this becomes 2 upon 100 divided by 2 upon 1000 plus 2 upon 100 divided by 2. So this is, so when we divide a fraction by another fraction, so when we do, I hope you have watched my videos on the fractions. There I have discussed that if you divide a fraction p by q by another fraction b by c, this is equal to p by q multiplied by the reciprocal of b by c, which is c by b. So this becomes 2 by 100 multiplied by the reciprocal of 2 by 1000, that is 1000 by 2, and over here we have 2 by 100, 2 is 2 by 1, so the reciprocal of 2 by 1 is 1 by 2, so this is this. So now you can cancel out, 100 cancels 1000 with 10, 2 gets cancelled, 2 gets cancelled, over here 2 gets cancelled, and this is 10 plus 1 by 100. So this is, so now, so this is this. Now if you remember that in a this is a kind of whole number plus a fraction, a proper fraction. Now if you remember that, now what is this 1 by 100? So now we have to do this addition. We can convert the fraction 1 by 100 to decimal, and then we will add 10 to 1 by 100. So this is 10 plus, now 1 by 100 is, if I convert this is a decimal fraction. How do I convert it to a decimal? I have already discussed in the beginning of this video. So it will be 0.01. Now how the 1 by 100 is 0.01? You have to understand the beginning of the video where I explained how to convert a decimal fraction to a decimal. So now this becomes 10 plus whole number plus a decimal number. Now this 10 we can always write it as 10.00 plus 0.01. So this is now basically an addition of two decimal numbers, two like decimal numbers, and the result is 10.01. So the answer is the choice will be C. This is the answer. This is the result. This is the result. Answer is choice C. Now simplify. Question number 3. It is a simplification problem. It asks to simplify 130.02 plus 113.26 minus 27.1 minus 17.4. Okay, so we have a simplification with addition and subtractions where we can see that all the decimals are unlike. They are not like decimals. So the very first thing we will do is convert all the unlike all the decimals to a like decimals. We can see that the highest decimal places is 2. So if we convert all the decimals to like decimals, it will be 130.02 remains the same, plus 113.26 remains the same, 27.1 becomes 0, and 17.4 becomes 17.40. Okay, now we have like fractions. Now if you have if you have watched the videos on addition and subtraction of decimals, I hope it was in the class number 3. So over there I discussed and explained that if you are asked to simplify an addition and subtraction of more than one decimals, then what you do is you first collect all the positive decimals at one place and all the negative decimals to another place. So let's collect all the positive decimals to one place. So 130.02 plus 113.06, and let's collect all the negative decimals to another place, and this will be 27.10 plus. So what basically we are doing is we are subtracting the numerical sum of all the negative decimals from the numerical sum of all the positive decimals. Now what is meant by numerical value of a number? That number could be anything, could be a fraction, could be decimals, could be natural numbers or whole numbers. The numerical value of a number means just the value ignoring its signs, ignoring its sign, that is positive and negative sign. Numerical value of minus 4.2 is 4.2. Numerical value of 6 is 6. Numerical value of minus 10 is 10. Numerical value of minus 1.1 is 1.1. I hope it's clear. So in this step, what we are doing is we are collecting all the positive decimals at one place, and with addition operation we are collecting all the negative decimals. Oh, I forgot one step. Sorry, extremely sorry. I forgot one step. After we have converted all the decimals to like decimals, what we will do is we will convert all the subtraction operations to addition operations. So in doing that, after converting all the subtraction operations, how do you convert a subtraction operation to addition? So this is minus, we are subtracting 27.10. That means we will add additive inverse of 27.10. Similarly, over here we will add additive inverse of 17.40, that is minus 17.40. This is from the fact that A minus B equals A plus additive inverse of B, that is minus B. This is the rule or fact behind. Okay, now you see that in the second last step we have 2 negative decimals and 2 positive decimals. So now we will collect all the positive decimals at one place with addition operation, and we will collect all the negative decimals without the sign to another place with addition operation. This is this. I have collected all the negative decimals with and added them without their sign. This is this, and the positive decimals I have collected at one place. This is this, and I will subtract this. I will do this. So this is what. Uh, so this will. So this is the now the simplified version of the evaluation I will do. Now I have to do the addition of the all the positive decimals and also the addition of all the negative decimals. So this becomes, if I add 130.02 and this I am directly doing this. This will be point 28 and 3 4 243 minus 243.28 minus and the addition of all the negative decimals, that is 27.10 plus 17.40 becomes and this becomes 1444.50. I hope I am right. Very prone to make mistakes, I mean calculation mistakes. This is 14. Okay, now we have to do this subtraction. These are like fractions. How do we subtract? We write the larger decimal first, and then below we write the smaller decimals in the column format, so that the decimal points and all the respective digits of the decimal part and the whole part are in the same column, and we subtract just like whole numbers, and this becomes 7 and okay, 12 5 8 9 1, and the decimal point will be, you can see that the decimal places of the two decimal numbers is 2, so 2 places 2 digit after 2 digits from the right. I hope I did the subtraction correctly. Let me quickly check. Yeah, so okay, so this is 198.78 is the answer. So is the result of the is the simplified value. So the answer will be choice D. Okay, let's do problem number 4. Problem number 4 says greatest number among, there are a few decimals given and it is asking to find the greatest. Okay, so the decimals given are 0.029, 0.003, 0.030 and 0.300. Clearly we can see. So how do we compare the decimal numbers? First we compare it by the whole parts. So of two decimal number, the one having a greater whole part is a greater decimal number, and if the whole part are same, then we compare the digits of the decimal part digit by digit from the left, and while doing that, if a digit if the digit of the decimal number which becomes greater than the corresponding digit of the other decimal number, then the former decimal number is greater. So we can see the whole part in all these decimals are 0. Okay, now we have to compare. Now we have to compare the decimal part. We have to compare this thing. These are the decimal parts, digit by digit from left to right. Left to right, we have to compare the digits left to right. So first we see that all the first digits are the first digits in the first three decimals are 0, but the first digit in the last decimal is 3. So definitely this is the largest. This is the largest decimal. So the answer will be A, choice A. Okay, let's see 5. 80 is excess over this by. 80 is excess over this by. So it is asking that how much 80 is excess over 73 point. So basically it is asking the difference of 80 and 73.865. This is basically what it is asking. So sometimes the language of the problem is a little difficult. It is becomes difficult to understand. So it's a matter of practice that you have to solve a different variation of problems, word problems, or where the problem is not directly given in mathematical terms but in words, and you have to understand the meaning of what it is asking and translate that to a mathematical problem, that is mathematical statement or puzzle. So this is what we have to compute for problem number 5. So this is a whole number minus a decimal number. So this is now we have to we have to convert both this to a like a decimal, and it will become 80.000, since the second decimal has decimal places of 3. So we have to now compute this. Now, okay, so we first write the larger decimal number, and below it we write the smaller decimal number in a column form, so that they are in same column, meaning the decimal points will be in the same column and the corresponding digits of the decimal part and the whole part will be in the same column. Now we do the subtraction just like whole numbers. So what will be the result? 5, 10, 7, 3, 9, 1 and 4, 6. Okay, so this is the result. I hope I am right. No. Okay. Look, so now where will be the decimal point in the result? The the two decimal numbers have decimal places of 3. So in the result, the point will come 3 digits from the right. So this. So the answer is 6.135 is the answer. Okay, so it is an MCQ. It is an MCQ. So we have to pick the correct choice, and the correct choice becomes 6.135. Oh, 61. What? 61 in the choice, it is given 61.135. No, it has to be, I think while copying the question from some source, I accidentally wrote it 61. It should be 6.135. Let me even check my answer quickly. So it is 80 minus 73.865. Okay, now if I do the subtraction, it is 5, fine, 5, 7, 3, 9, 1, 4, 6, 8. Okay, yeah, it should be B. It should be B, but in the question paper it is given 61.135. I'm quite sure it should be, the choice B should be 6.135. Okay, let's do problem number 6. This is a word problem. The length of a rope is 23.225 meter. Okay, if two pieces of length 6.42 meter and 3.09 meter are cut, find the length of the remaining rope. Okay, so total length of rope is given as 23. It is given in decimal. I'm omitting the unit meter. It's understood. So total length of rope is this. Two pieces of length this and this are cut. So total length of two pieces is 6.42 plus 3.09. So therefore, find the length of the remaining rope. Length of remaining rope now becomes the total length, that is 23.225 minus the total length of the two pieces. So this is 6.42 plus 3.09. So this is what we have to evaluate. We have to evaluate this now. Okay, 23.25 minus 6.42 plus 3.09. Okay, fine. We can see the all the decimals are already like decimals. They have the same decimal places of 2. So first we will compute this. So this becomes 23.25 minus, I am doing the addition of the two decimals directly. So this becomes 11 and 5, 9. Okay, and okay, now we have to do this subtraction. So 23.25, 9.51, it becomes 4, 5, 7, 12, 10, 3 and 1. The decimal point will be over here. So 13.74 meter is the result, is the answer, the length of the rope remaining. So the choice is C. Okay, the choice is C. Let's do problem number 7. By how much is the sum of 44.44 and 32.03 greater than their difference? By how much is the sum of 44.44 and 32.03 greater than their difference? So sum of 44.44 and 32.03 is this. The sum is this. It is asking how much is this sum greater than their difference. Now their difference is 44.44 plus 32.03. Basically we have to evaluate this. Now when you see this kind of simplification, always first check if any decimal values are cancelling or not. In this case it is this will be minus. So this is the sum of the two values, and this is the difference of the two values. So in a subtraction and in a simplification, in an expression like this, if you see in an expression of decimals or any numbers with addition and subtraction, if you see two numbers are cancelling, always do that first. We can see that 44.44, the first 44.44 will cancel with what is now, see if I simplify this, this is nothing but 44.44 plus 32.03 minus 44.44 and this is plus 32.03. So you can see clearly that this, the 44.44 is cancelling out, and you are left with you are left with 32.03 plus 32.03. Basically this is equals to 2 into 32.03, but we have not discussed the multiplication of decimal numbers, so we will not do it this way. Rather we will, so we are left with this, so 32.03 plus 32.03, and if you do the addition simply by adding the two decimals as we have discussed earlier in previous classes, this becomes 6406. Okay, so this was a short question. So the answer is 64.06. So the main concept over here was to translate the given problem into mathematical statement. I mean, this is the mathematical statement. This is what we have to find in terms of mathematically we have to find this, and in this kind of simplification problem, you always first check whether any terms are cancelling or not. Like if you see any number and its additive inverse, then they will get cancelled. I mean, the sum of a number and its additive inverse is always 0. So that is the reason 44.44 got cancelled with minus 44.44. So the answer is 64.06. Okay, let's do problem number 8. Let x, y, z are digits. X, Y, Z are digits. Okay, which choice is correct? If x, y, z are digits, okay, it is given that 3 point x to z is less than 3.0 y z less than 3.z. So since x, y, z are digits, so it's basically it's a problem of comparing decimal numbers, but x, y, z are digits. Okay, now if this ordering is true, so it's given that this is true. We can see that all the decimal numbers, the whole part is same, 3 is same. So we now have to compare, to check whether this ordering is correct or not. We have to compare the decimal part of all the 3 decimal numbers. So we can see that so definitely if this is the case, if this is the ordering, this implies point x to z will be less than 0 y z. This will be the case. Now we have to compare. If we compare the decimal part, first we have to compare x. The first digit of the first decimal part is x, and the first digit of the second decimal part is 0. Now x, as you can clearly understand, x has to be less than or equal to 0. Now since x, y, z are digits, x has to be equal to 0. This implies x has to be 0. X has to be 0. X cannot be 1 or 2 or 3. Then it will, then the whole this whole decimal part, the 0.x to z will be greater than 0.0 y z. So x has to be 0. Okay, we got this. Now also if this is the case, so we get that 0.02 z less than 0.0 y z. Now if this is the case, then we can say something, what we can say about y. So now the first digit in the decimal part is same, 0 0. Now we have to check the second digit to the right, that is we have to check 2 and y. We will compare 2 and y. So if this decimal part is less than this decimal part, then obviously y should be greater than or equals to 2. No, y cannot be equals to 2, because you see the third digit is z. Z is same, but for 0.023 to be less than 0.05 y z, then y has to be greater than 2. Y has to be greater than 2 because the third digit is same, and so for the first decimal part, to be less than the second decimal part, it has to be the case that y is greater than 2. So we must have y greater than 2. Okay, so we got y greater than 2. What else we can get? Y greater than 2. Also, what about the 3 point z? What we can say about z? Okay, so we have 3.0 by z is given less than 3 point z. Now see, if you compare, no, we can say that since 3, okay, fine, we are given this implies point, the decimal part, that is 0.0 y z has to be less than point z, because the whole part 3 are same. If this is true, then what we can say about z? First, to compare the decimal part, we have to compare digit by digit. So the first digit in the first decimal part is 0, and the first digit in the second decimal part is z. So this implies z has to be greater than 0, has to be greater than 0, it cannot be 0. It cannot be 0. It cannot be 0, it has to be greater than 0. So now we got these three information about x, y, z. Now we have to check the options. We have to check the options, what is coming true. The option A says x plus y plus z greater than 2. Now if you see that x is equals to 0, it doesn't matter. So the first choice is x plus y plus z. To verify this, since x is coming to be, we have found that x is 0, this implies that it is trying to say y plus z greater than 2, and which is true because y itself is greater than 2 and also z is greater than 0. Since we have these two fact implies that y plus z greater than 2. So A is true, A is correct. Now what about x plus y plus z greater than 3? No, x plus y x plus y plus z need not be always greater than 3, because we only know that a y plus z is greater than 2 and y is and z is greater than 0. Yes, so we know that y plus z is greater than 2. Y plus z is greater than 2. Now the option choice B says x plus y plus z. We can ignore x because x is 0. It is trying to say that y plus z is greater than 3. No, it need not be. It can be 3. Y plus z can be 3 because we have found out that y plus z is only greater than 2. We only know that y plus z is greater than 2. It could be 3, it could be 4. So we cannot for sure say that y plus z is greater than 3. So choice B is false. What about C? X, Y, Z greater than 0? No, x is 0. So definitely x, y, z is x, y, z has to be equal to 0. So C is false. C is false, and none of these. D is none of these. So definitely the answer is A. X plus y plus z greater than 2. Okay. This was a little tricky question that I designed this question by myself just to check the knowledge of how do you compare decimal numbers based on the whole number and the decimal and the digits and the decimal part. When you compare the decimal part, you compare digit by digit from left to right. Okay. Now let's solve question number 9. What should be subtracted? This is a word problem. What should be subtracted from the sum of this and this so that the difference is this? So it is asking that what should be subtracted from the sum of this. Okay, first write down the sum of 2.58 plus 1.471. This is the sum of the two numbers. It is asking what we should subtract from this sum. What I am writing a box to give to, we have to solve the box. So what, let's say if this is x, what x should be subtracted from the sum of these two numbers, decimals, to give 2. So from here definitely we know, we can say that x equals 2.58 plus 1.471 minus 2. So this is what the mathematical puzzle or statement we have translated to from the given word problem. We have to find this. Okay, so these are, we have three decimals. 2, we know that 2 is a whole number, but 2 is nothing but we can write it at 2 point any number of zeros. So but the first two decimal numbers are unlike. We have to convert all the decimals to like decimals, and that and it will become 2.580 plus 1.471, and 2 we can write 2.000. Okay, if we do the addition of the first two decimal numbers, we get, I am directly doing the addition, we get 115 and 4. We get 4.04051. Let me quickly check once again. 1 and 15, 9, 10. Okay. So now we have to find the subtraction of two decimal numbers. They are like decimals. So how do? We write the larger decimal number first, and then in column form below the larger decimal number we write the smaller decimal number and do the subtraction just like whole numbers, and the result will be 1 5 0 0 and 2, and the decimal point will be since the decimal places of the two decimal numbers 4.051 and 2.000 is 3, the decimal place in the result, the decimal point in the result will be 3 digits from the right. So the answer is 2.051 is the answer. Let's do the last problem. This is what should be added to the difference of this to get this. It's kind of reverse problem of the problem 9. What should be added to the difference of? Now the difference of 6.88 minus 4.25. It is asking what should be added. What should be added? This is the box. The box should be added to give 5. Okay. If this is x, this implies we know that x will become 5 minus 6.88 minus 4.25. So this is the value that we have to evaluate. That will be the result. Now, okay, so let's convert all the decimals to like decimals, and this will become 5.00 minus this is 6.88 minus 4.25. Now let's do the addition of the two given decimal numbers. This will be, that is 6.88. Oh no, this is subtraction. So we have to first do you can do one thing, you can do the subtraction first, and then from the result you can subtract from 5, or either way, I mean it will take the same time, or you can do is, if you open the parenthesis, I mean this will be minus 6.88 plus 4.25. So this is now this is 5.00 plus minus 88. This is what I already discussed, how to simplify an expression of decimal numbers with addition and subtraction. You first convert all the decimals to like decimals, and then convert all the subtraction operations to addition operations, like we did minus 6.88 to plus addition of additive inverse of 6.88, that is minus, and then we group all the positive decimal numbers together like this, add all the positive decimal numbers together, and we subtract from this, we subtract the sum of all the negative decimals but without their sign. So this is basically 6.88. So now if we add 5.00 and 4.25, this becomes 9.25 minus 6.88. Okay, now we have to do this this subtraction, and the subtraction, the result becomes 7, 9, 3 and 2. So the answer is 2.37. Let me check quickly once again. 9.25, when we subtract 6.88 from 9.25, it is 715, 912, and I hope it's right. So this is the answer of the question number 10. So that was it. I hope this set of problems will help you apply your concepts on decimal numbers regarding all the topics we have discussed, that is addition, subtraction of decimals, and conversion of decimals to fractions to decimals, comparing decimals. All these concepts will be evaluated well from this set of problems. If possible, I will prepare another set of problem, the sample number 2, based on the same topic later on, but the next video will be on the multiplication and division of decimals, which I will try to upload that video by today itself. So thanks for watching, and once again, if you are not yet subscribed or new to my channel, please support me by subscribing to my channel and share my videos with your friends. That will grow my channel and will motivate me to come up with this kind of videos on regular basis. So that's it. Thanks for watching, and until the next video, take care and bye.